Welcome to students, Maths with Balakrishna sir. In last class, I am explaining the introduction of polynomial topics. What are the topics in last video I am explaining? What is the polynomial, types of polynomials, zero and quotients. Next, the relation between zeros and quotients. Okay, here now going to example. Okay, example 1. Let p of x is equal to x square minus 2x minus 3. P of x means what? Polynomial with variable x. P of x means what? Polynomial with variable x. So here x square minus 2x minus 3, it is a polynomial. Its first term degree is 2, next term degree is 1, next term degree is 0. Okay, so here it is a polynomial. Find the value of p of 3 and p of minus 1. Here p of 3 means in the place of variable we can substitute numerical. Here what the numerical given? 3. So here first given p of x is equal x square minus 2x minus 3. P of in the place of x we can take that 3. So here 3 square minus 2 into 3 minus 3. 3 square 9, 2 3 ja 6 minus 3. 9 minus 6 minus 3 9, 9 minus 9 0. So here at the variable, at the place of variable x we can substitute 3, then the polynomial is become 0. Therefore 3 is the 0 of the polynomial. Next, p of minus 1. P of minus 1 means in the place of variable we can take minus 1, that is here minus 1 whole square minus 2 into minus 1 minus 3. So minus 1 whole square, the negative integer is multiple even times, it is become positive. Minus 1 whole square, that is 1, minus minus plus 2 1 ja 2 minus 3, 1 plus 2 3, 3 minus 3 0. So p of minus 1 is equal 0. So therefore 3 minus 1 are zeros or roots of x square minus 2x minus 3. Okay, what is called 0? The value of variable, any numerical value, in the place of variable you can substitute any numerical value, then the polynomial is become 0. That numerical value of variable is called 0 of the polynomial. Here what are the zeros? 3 and minus 1. In the place of x we can take that 3 is a numerical, we can get 0. Next minus 1 we can get 0. So this is the way. Next example 2. Find the zeros of the polynomial 6x square minus 3 minus 7x and verify the relationship between the zeros and the quotients. So here verify the relation between zeros and quotients. Okay, first the given polynomial is quadratic polynomial. The quadratic polynomial, how many zeros are there? 2 zeros. Its degree is 2. We can get 2 zeros. Okay, here what is the relation between zeros and the quotients? That is the sum of the zeros is minus quotient of x by quotient of x square. Product of zeros is constant by quotient of x square. Okay, so first find the zeros. Okay, here given p of x is equal 6x square minus 3 minus 7x. First the polynomial we can write in order form. So here p of x is equal 6x square minus 7x minus 3. Okay, for this polynomial find the zeros. Okay, how we can find? By taking assume method. Okay, here let us take p of x is equal 0, 6x square minus 7x minus 3. So here for the quadratic polynomial we can find the zeros. There is 4 methods are there. There are factorized method, algebraic identities method, next complete square method, next graphical method. So here we can take that factorized method. Here how we can find? X square quotient is 6, constant is minus 3. Okay, 6 into minus 3, that is how much? Minus 18. So the minus 18 factors, there's any two factors of minus 18, we take any two factors, their sum or subtraction is become x quotient. Okay, here 9 into minus 2 plus into minus, minus 9 2 ja 18. Okay, or minus 2 minus 9 into 2 minus into plus, minus 9 2 ja 18. So here minus 9 plus 2 is how much? Minus 7. Okay, if you take any two factors, their sum or subtraction is become x quotient. Here x quotient is what? Here minus 7. So in the place of minus 1 you can take as minus 9 into minus 9 plus 2. Okay, minus 9 into 2 is how much? Minus 18. 9 into minus 2 is also minus 18. We take any more. Okay, so that is here 6x square minus 9x plus 2x minus 3 is equal 0. Okay, from these two what the common? Here 6x square means 2 into 3 x into x, 9 3 into 3 into x. Okay, so here 3x is taking outside. What the remaining? 2x minus 3. From the last term there is no common, so 1 is common multiple of any number. So let us take 1 outside, that is 2x minus 3 is equal to 0. In this two expression what the common? 2x minus 3. 2x minus 3 of 3x plus 1 is equal to 0. So the product of two polynomials is 0. Either first polynomial is 0 or second polynomial is 0. So that is here 2x minus 3 is equal to 0. 2x is equal to 3. X is equal to 3 by 2. 3x plus 1 is equal to 0. 3x is equal to minus 1. X is equal to minus 1 by 3. So for this quadratic polynomial, what are the two zeros? 3 by 2 and minus 1 by 3. So here what is the relation between zeros and coefficients? Sum of the zeros is minus b by a. Okay, product of zeros is c by a. Okay, here x is equal to 3 by 2, x is equal to minus 1 by 3. 3 by 2 minus 1 by 3 are zeros of 6x square minus 7x minus 3. So here let us take alpha is equal to 3 by 2, beta is equal to minus 1 by 3. So alpha plus beta, that is equal 3 by 2 plus minus 1 by 3, plus into minus minus. So 3 by 2 minus 1 by 3. These two are fractions. We can do that cross multiple. 3 3 ja 9. 1 into 2 2. 2 3 ja 6. 9 minus 2 7 by 6. So alpha plus beta is equal to 7 by 6. Next alpha into beta, that is 3 by 2 into minus 1 by 3. Okay, here 3 3 cancel. So what is the remaining? Minus 1 by 2. So here the polynomial a 6x square minus 7x minus 3. Here x square quotient is 6, x quotient is minus 7, constant is minus 3. So here sum of the zeros, alpha plus beta is equal minus b by a. So here a is 6, b is minus 7, c is minus 3. So that is here minus of minus 7 by a is 6, minus minus plus 7 by 6. Next alpha into beta, that is c by a, constant by quotient of x square, constant is minus 3, x square quotient is 6, 3 1 ja 3 2 ja, that is minus 1 by 2. Alpha into beta is equal minus 1 by 2. So this is the relation between zeros and quotients. Find the zeros of the polynomial f of x is equal to x square minus 2. Okay, f of x means what? Polynomial with variable x is equal to x square minus 2, and verify the relationship between its zeros and coefficients. So here given f of x is equal to x square minus 2. For this polynomial you can find the zeros. Okay, how we can do that? Let us take f of x is equal to 0. Okay, let us take f of x is equal to 0, that is x square minus 2 is equal to 0. Minus 2 is going to set up n plus x square is equal to 2. So the square is going to set up n square root. Okay, so which is square root? Plus or minus square root. The square of any integer, there is two values are there. What are there? Plus and minus. Okay, here x is equal plus root 2 and minus root 2. Here how many zeros are there? Two zeros. Here the quadratic polynomial having two zeros. Its degree is 2. Okay, its zeros are 2. Here what are there? Root 2 and minus root 2. So here plus root 2 minus root 2 are zeros of x square minus 2. Now check that root 2 minus root 2 are the zeros of x square minus 2. Here let us take alpha is equal to root 2, beta is equal to minus root 2. Okay, here these two are zeros of x square minus 2. Here x square minus 2, here when you comparison with the polynomial ax square plus bx plus c, here a is equal to 1, b is equal to 0, Here x quotient, there is no x quotient, we can write as 0 into x. So constant is c is equal to minus 2. Okay, here alpha is equal to root 2, beta is equal to minus root 2. Alpha plus beta, that is equal root 2 plus minus root 2, plus into minus root 2 minus root 2, that is equal to 0. Alpha plus beta is equal to 0. So when comparison with quotients, here minus b by a, so that is here minus 0 by a is 1. So 0 by anything, 0. Okay, next alpha into beta, that is root 2 into minus root 2, plus into minus, here root 2 into root 2 whole square, square root cancel, that is minus 2. So the product of zeros when you comparison with zeros, that is c by a. C means constant, a is the quotient of x square. So that is here c by a, that is here c is minus 2, a is 1, minus 2 by 1 minus 2. So this is the relation between zeros and quotients of a given quadratic polynomial.